Hello everyone. So in this particular video, we will be looking at convolutional neural network. It appears to me that this particular topic, convolutional neural network, will be split into two videos. Part one, where I'll be dealing with the theory and one in-depth kind of a running example. And in the second video, we will be coding. So if you already know everything of convolutional neural network, or at least you know you have implemented it before, then you can skip it. Otherwise, you should definitely stay along, because I'm going to break down each part in a very finer details, and then I'm going to explain it to you. Okay, so without any further ado, let's get started. So what are the things that we're going to cover in this particular video? So the first one is going to be the convolution operation itself, along with padding and strides. So this together comes as one. Then second, we will be using the Maxpool, and hence we will be studying what Maxpool is and how to do it with an example. And lastly, we will be seeing how to flatten the particular data that we have, and how to use a fully connected layer to be able to do classification. Okay. This is the full pipeline of CNN. This is how it works. So first we do padding and convolution. This is one operation, one line of code in PyTorch. You will see when we will implement it in the next video. Then we are going to do a Maxpool operation. This is again one line of code. Then flatten. Then we will after flattening it, we'll multiply it with a linear layer, and then we will finally do a classification using sigmoid. Okay. So you keep in mind this full pipeline. Now, the first thing is convolution that I'm dealing with, and you need to understand, in a convolution there is an image which is shown over here, 5 by 5, the five rows and 5 columns, and this red one is actually the kernel. Here I'm trying to show you kernel or mask. Mostly they use the word kernel, but in image processing, if you have studied, mostly people use mask. Okay, both are fine, both are the same. What happens is, I am trying to explain to you how convolution works. Okay, so we are dealing with how convolution works. So first time what will happen is, you'll have and we will see an example, don't worry, I'm just showing you the movement right now. So you will have an image which is shown in black, this 5 cross 5, and then a kernel is put on top of it. Okay, so firstly the kernel will be like this, as you can see over here. In the next, the kernel will move one step to the right. Now I'll explain what stride and everything is, but just keep in mind, it will go one step to the right. It will skip one column and go to the right. Then what will happen in the next iteration? Obviously it will skip one more and it will go to the right. You see over here, it skipped one more. Now what will happen after this? After this you will see that it will skip one row and come back to the first column. So it skipped one row. I mean, it obviously it finished the entire row, and hence it came to the next row, and the mask is put like this. And same way, if you go faster, you'll see then, if you are doing it with me, you will see that it will come over here, then again it will go down, and here, and here. So this is how a kernel moves in convolution. Some people have confusion with this. That's why I've explained. Now let's see with an example, with a concrete example. So in this case, this will be our image 5 cross 5, and this is going to be our mask. Okay, mask or kernel, you can also use kernel. So what happens, as I told you, the mask will be fit, or will be, overlapped over here in the first position. So it will take 3 cross 3, this much. What will do is, it will take the value of the mask and multiply it with the corresponding value of the image at that position. So you see if you see the red values, these are the masks values. Okay, 1 minus 2 1 minus 1 0 minus 1 1 minus 2 1. So you can see these are the same values here, and these values are the image. So what it will do pointwise multiplication. So 1 into 5, you can see over here I have written for you 1 into 5, and the answer is 5. Then minus 2 into 0, minus 2 into 0, 0. 1 into 1, 1 into 1 is 1. Minus 1 into 2, minus 1 into 2. And so for wherever there is the overlap between the kernel and the image, or mask and the image, you will have the pointwise multiplication, and at last you will add all of them. Once you add all of them, you will get the number 5. So you will take you'll have an empty um, let's say an array or a tensor, obviously tensor, and then you will write the value of that. Now, as I told you earlier, how the kernel moves, it moves one step to the right. So it moves one step to the right. Now again you have some the kernel is placed over this image at this position. Now again they will be pointwise multiplication. 1 into 0, 1 into 0 is 0, minus 2 into 1 is minus 2, then again here 1 into 2 is 2, minus 1 into 3 is minus 3, and so on for all the 9 values. Okay, if you add all of them you'll get minus 10, and hence you have here minus 10. Third position, again you do the same thing, you multiply all of them, add, and you get minus 1. Fourth position, if you remember, it will come one step down because it has completed the entire traversal through this row, so it has come down one by one row, and now it is starting from the this side. And then again you can see point to same thing, point was multiplication, then addition, you get minus 2, and then you write it out here minus 2. So if you do this for all the possible positions, you will see you'll get a 3 cross 3 kernel, or not a kernel, you get 3 cross 3 tensor, and these are the values. Now how will you know mathematically what is going to be the output? Well, this formula tells you this O is going to be the kernel size. Okay, kernel, I'm not saying I shouldn't say kernel, this is the tensor size. Okay, what is N? N, you can see it's the input size. Input size is 5 cross 5. Well, it can depend on 2 dimensions, but since we are using only the square matrices over here, this image is 5 cross 5, the kernel is 3 cross 3, so we are using only square matrices. So N will be 5. It is the input size, which is the or the image size, input size or the image size. Kernel size, we know kernel size is 3 because it is 3 cross 3. Padding I haven't explained, but right here you can see padding is 0. There is no zeros added, so padding is 0 for you. And stride is 1. I'll explain what stride is. So if and add means calculate this and add plus 1, so whatever will happen, whatever you will get, you can say this will be the value. So out here if you do the calculation, you will say 5 minus 3 plus 0, that is 5 minus 3 is 2, plus 0 is again 2, 2 divided by 1 is again 2, and 2 plus 1 is 3, so you will get 3. We will see in this in some time, we will have a concrete example. So now we will see padding. Okay, what is padding? Padding is basically, this was your image. If you remove these zeros from the sides, this was the image 5 0 1 2 4. See, 5 0 1 2 4 and 5 2 4 5 0. 5 2 4 5 0. So this was actually our image itself. Okay, what we did a padding of 1, that is we added one row of 0 on the top, one row of zeros in the bottom, and one column of zeros in the right hand side, and one column of zeros in the left hand side. This is padding equal to 1. Now can you guess what is padding equal to 2? Yes, it's easy. You add 2 rows of 0 on top, 2 rows of zeros in the bottom, in the left and in the right. So if padding is n, then n rows in the top, in the left, in the right, and in the bottom. Okay, so that was padding. So now let's try to do convolution on the padded image. Okay, so I'm not going to go step by step because I have explained how all of it works, how convolution works, and how operation is done. So basically you can see the kernel is put over here, and then you'll get some value, and then you see the kernel has moved to the right hand side. Again it moves in the third position. Okay, so it goes this way and it'll go all, I have explained how it does, and same procedure, and this you will be getting over here the final tensor. Okay, and this was the mask or the kernel, whatever you want to say. Fine. So now if I want to find out the what to say final dimensions, okay, the output O, n was 5 itself, right, because padding was on. So n was 5, image size hasn't changed. K was 3, if you remember, you can see over here 3 into 3, 3 cross 3, plus 2 into padding. Earlier padding was 0, now padding is 1, and S is 1. I'll explain the next slide what is stride. Okay, so what you're going to see over here is 5 because the image stayed the same, minus 3 is the kernel size, plus 2 into 1, that is 2, that is padding was 1, divided by 1. What you will get, that is 5 minus 3 is 2, 2 plus 2 is 4, 4 divided by 1 is 4, and 4 plus 1 is 5. So what you are going to see is this image size was 5, and the output that you got, we will see next in the output that you got 5 cross 5, it is the same as the image size after padding. So what you can see is that the size did not reduce. In the last example, if you remember, you see size reduces from 5 cross 5, we came to 3 cross 3 because padding was not there. Fine, hope till here it is clear. Okay, now what is stride? Now if you remember in convolution what I said, it will go for the first 3 cross 3, and after that what it will do, it will go for the next element like this. It will come over here. That is what I said. Here when you are talking about stride, it skips one step. So ideally what should it be doing if stride was equal to 1? It would have come at this position, right? But it did not come at this position. What happened? It skipped one position and it came over here. So this is stride equal to 2. Now if can you guess what will be the next position? It will be it will spread this it will skip this one and it is going to come over here. Okay, over here you can see in the next one. See, it came over here. Now again what it will do, it will skip one row and go down. But in stride equal to, here it should be 2. Okay, I have mistakenly written 1, it should be 2. What it will do, it will skip this row. Okay, it will come down over here, it will come down over here. It skipped this row. If the stride was equal 1, again this is a mistake, let me see if I can correct it right now. This one is, it's not 1. I'm using a mouse, so forgive me for that. Okay, so it's not 1, it's 2. So it will skip this particular row and it will come over here. Now can you guess what will be the next step? Obviously it will come and go over here. You can see over here, it went here. Again, next step, easy to guess, it will leave this one and it will come over here. You can see. Okay, then again this one, then this one, and then finally this one. Now how to calculate it over here? Again we'll use the same formula. This formula will only be used. So n was 5 because we did not change the size of the image. K was 3, padding was 1. However, stride s was 2 this time. Okay, you can see here it is written correctly. Stride is 2. If you solve this, you'll get equal to 3. So in this case again size reduced. So you have to remember that padding and stride change the output of the tensor that we get. Okay. Now we are going to see Maxpool. Now what is Maxpool? Maxpool is basically, it's very easy. Okay, it depends on the size. Again, kernel had a size of 3. We are using Maxpool as a size, having a size of 2. Here it is a lot more easier than that. What you will do is you will take a square of size Maxpool. If this is 2, then 2 cross 2. Okay, it's always, at least how I have seen, it is always a square. Okay, it will be 2 cross 2, 2 cross 3, sorry, 3 cross 3, 4 cross 4, 5 cross 5, 6. Okay, not 5 cross 5. It will be 2 cross 2, 3 cross 3. It can be 5 cross 5. Mostly what I have used, I'm telling you that. It can be 7 cross 7. I have rarely seen 6 cross 6. So I'm just telling you, it is based on my personal experience. The ones that I have used and the ones that I have seen. Okay, so here you have 2 cross 2. Now what is going to happen? It will take the, as it says, maximum of this. So what is the maximum of this? Or basically you take it out and write it over here. So 5203, again here 5203. What is the maximum of that? Again 5 is obviously, it is the greatest number. So you will see you will have 5 over here. So now what will happen? It will not take like convolution. It will not become over here. It will directly go over here. Okay, it will directly go over here. See, it came directly over here. Now again, what is the maximum over here? Then it will take down. Okay, 1 2 3 5, 1 2 3 5. What is the maximum of that? 5. Now what will happen? It will not go over here, it will directly come over here. Okay, so it will come over here, you can see, at this position. Now what is the maximum? 4152, 4152, again 5 is maximum. Then again it will come over here, it will skip this one. What is the maximum? 2143. The maximum is 4. Then you will have 4. So this is how max pooling works. Now what if there was another column over here? Then yes, it could have fitted and then you would have another column over here. Okay, so this is how it works. Again, there are obviously other things like stride is also there, but I have really kept it to very small explanation. Okay, then let's have a running example so that we can have a proper understanding of how all of it works. So first I told you, you'll have the image and then you will pad. Okay, with padding equal to 1. So we padded the entire image. What is padding? Very quickly, adding 1, or if this is n, then n row on the top of zeros, n row of zeros in the bottom, n rows, n columns of zeros on the right, and n columns of zeros on the left. So if it is 1, if n equal to 1, you'll have 1 all that in all the 4 directions. Now you'll do convolution. I've explained convolution. I've explained how convolution moves. So basically stride equal to 1 over here. I should have mentioned, but stride is equal to 1, and you do convolution and you get this. Okay, so obviously with stride equal to 1 and padding equal to 1, the image size did not change from 5 cross 5. We added a padding, but the image is still 5 cross 5, and the output we are still getting is 5 cross 5. And this is the mask that I have used. This is the kernel that I have used. Okay, you can use if you use scipy convolve and dimage.convolve, you'll be able to use this, or you can also use PyTorch. Now Maxpool, I have explained what Maxpool is, so going really quickly. First of all, you are taking 2 cross 2, so you'll have this over here. What is the maximum value? 5 is the maximum value, so 5. Here, what is the maximum value? Since all are negative, 0 is the maximum value, so you'll have 0. Over here, what is the maximum value? You will see minus 2 is the maximum value, because minus 10, minus 8 are greater than minus 2. And here, what is the maximum value? You will see minus 1 is the greatest value. Okay, and then we will leave this because it's we do not have one more, so that we can use it. Okay, so we will just leave it over here. We got this 5 minus 2 0 minus 1. After Maxpool, if you remember, there was flatten. Okay, after Maxpool there was flatten, so we got this in the last step. Okay, we got this in the last step. Now what you can do is flatten. Obviously this is a matrix. You need if you are saying you have to flatten, you have to convert it into a list. Okay, list or whatever 1D tensor. So what happens is you can do it either row wise or column wise. Row wise means you take the first row, and then after the last element of the first row you append the second row. So 5 0 minus 2 minus 1. So 5 0 minus 2 minus 1. So I took this row wise first row, then second row I read. However, if you take column wise, you take first column then second column. So first column is 5 minus 2 and second column is 0 minus 1. Now I mostly use row wise. So while I was implementing CNN using NumPy, so I mostly use row wise. It doesn't matter, you can use row wise or column wise, and you will not have to think, because we will be using the flatten function of PyTorch, so you will not care, even though you can change if you want. So I mostly use row wise. Okay, now the linear layer. So if you remember the pipeline again, it was linear layer was there. So what happened until here, we got this much, and we have chosen this one 5 0 minus 1 minus 2. So 5 0 minus 2 minus 1, sorry. Now these curved lines are just that values are being sent. Okay, no calculation is taking place here. Okay, I didn't want to mess up, that's why I have done this way. So here you will get 5, here you will get 0, here you will get minus 2, and here you will get minus 1. Now this is basically a linear layer that we have seen in the linear regression up till here. So what will happen, you will have some values, some weights, w0, w1, w2, w3. Here I have assumed some random weights. Obviously these will be learnt during training. So what will happen, your first w0 will be multiplied by 5. There, if you have a bias, then you can have a bias. So if there can be definitely a bias if you want. However, if you want to not have a bias, you can definitely say bias equal to false in PyTorch. So I have assumed in this case that we do not have a bias, so that we don't add an extra complexity. That's it. What will happen, this equation will be followed. All w0 will be multiplied by 5, w1 will be multiplied by 0, w2 will be minus 2, and w3 with minus 1. So you know linear regression, I hope. So again, w0 into 5, so w0 value is 0.1 into 5, then w1 and w1 into 0, w1 is minus 1.3 into 0, then w2 is 2.9, and the minus 2 comes from here, and w3 is minus 2.4, and minus 1 comes from here. So again, if you substitute all the values, you get y dash, that is here you are getting minus 2.9. The last thing that we had was using a sigmoid for classification. So y dash we got in the last step as minus 2.9. We will use the definition of sigmoid, and we get 0.052. Now what does this mean? That the probability of this whatever image that we had taken earlier, if you remember this image, the probability of this image so what this means is the probability of the particular image that I had shown earlier belonging to the first class. Now it depends what was the first class. What PyTorch assumed to be the first class is 0.052, or multiplied by 100, that is 5.2%. So there is a 5.2% chance that the particular image that we had seen earlier belongs to the first class. Now what is first class? It can be, if you are doing a cat dog prediction, that it could be a cat weighs 0, then dog will be 1, or if you are doing let's say any binary classification. Okay, then the first class, whatever is the first class, the probability is given here. So what is the probability of the second class? 1 minus this. So there will be roughly around 95% chance that the particular image that we had belonged to the second class. So this was all the theory with respect to your convolution neural network. In the next video we will be implementing it, and if you want more one-to-one kind of interaction, go on to my Fiverr page. If you have a small question, then ask in the comment section, or you can directly message me on Instagram. I check Instagram couple of times in the day, and also my Fiverr page. So thank you very much, and bye.